Good afternoon, everyone. My name is Jeffrey Joy. Thank you for joining UMass Extension's Landscape, Nursery and Urban Forestry program on the Laboratory of Medical Zoology for the last webinar of the 2019 Take Talk with Take Report webinar series. This webinar will be recorded and archived on the UMass Extension website. Our speaker for this webinar is Dr. Stephen Rich, who is a professor of microbiology and director of University of Massachusetts Laboratory of Medical Zoology. Today, Dr. Rich will speak about the 2019 tick updates from the UMass Laboratory of Medical Zoology and the current Eastern Equine Encephalitis, that is EEE outbreak impacting much of Massachusetts this year. If you have any question during the webinar, please type it in the question box on your control panel, and Dr. Rich will answer the questions at the end of the webinar. After the webinar, there will be a short survey. Please complete the survey before exiting the webinar. Without further ado, here's Dr. Rich. Dr. Rich, you have the controls.
Great, thank you, Jeffrey, and good day. I'm opening here with a presentation. I had asked Jeffrey to send, is it showing okay? I'd asked Jeffrey to send a link to menti.com, which is a polling tool that we use. This will just help us to get some idea of who you are or who our audience is, and it will help us to frame the conversation today as well as future presentations so that they meet the needs that you're looking for. So I'm asking people, if they would, to go to menti.com, either through the phone app if you downloaded it or through your web browser now, and just point to mentimeter.com and enter the code 280016. And then if you would, just answer this question about your city, town, and state so that we can get an idea of where you're all coming from. Great, thank you for all those of you that are contributing there. It's helpful. And I mean, obviously, one of the reasons that this information is useful is I'm going to be talking a little bit about the geographic distribution of these risks. And it's good for me to know where you all are coming from, because what happens in California isn't necessarily the same thing that happens in Massachusetts or the same kinds of risks. Oh, great, we have quite a good distribution of folks. Thank you for all of you that contributed to that. So in a moment here, I'm going to go to the next slide where I'm asking a little bit more about what your role is and what brought you here today. Oh, pardon me. All right, the other thing I'd like to know, in addition to understanding where you came from, I'd like to know a little bit about just what your role is, whether you're a professional in the green industry and or a healthcare provider, or perhaps just the homeowner and concerned parent that's trying to get information for your family. Maybe you're a school nurse or a teacher, or something else that doesn't quite fit into this category. And if you're putting other, please feel free to, in the comment box on the webinar, to let us know what that other, what your other roles are. Again, thank you for taking the time. This is helpful to us. Helps us to make the presentations catered more to what your needs might be. And incidentally, we appreciate those of you that responded to our questionnaire. We sent an email around earlier. I did look at those, at your comments, and I think the information that you were concerned about or the information you're looking for. And I've tried to cater part of today's presentation to meet that need. Obviously, we can't get everything, but I have really done a bit of a turn in what I had originally planned to do based on the needs that were prescribed by the people that are here today. Okay, just one more of these slides. So this is a bit related to the previous one. I'm just wondering whether you are here because you have a role to play for helping other folks, or whether you're most concerned about what's happening in your own household, your pets, your family, etc., in terms of the risk of ticks and or mosquito-borne diseases. And again, so what I'm getting here is that there's not exclusively people from the state of Massachusetts. It looks like the greater northeastern area. I saw Pennsylvania and New York there. That there's a large representation of people from the green industry, but people from other walks of life as well. And that a number of you are identifying that you play some role, professional or otherwise, where you're responsible for the well-being of people other than those in your immediate household. So that's very useful information for us. Thank you. So now I'd like to go into the presentation. All good? All right, so what I wanted to do today was give you a little bit of a fall update of risks and tick risks and disease. I had initially intended to talk a little bit about infection rates and what we're seeing through our passive surveillance program here. I'm going to do less of that because it seemed that people were still asking a number of questions about prevention and control and the different measures that could be used there to control ticks and to a certain extent mosquitoes. I'm also aware that here in the state of Massachusetts and throughout the Northeast, concerns in the most recent months have not been necessarily about ticks, but more about mosquitoes, as we see a lot of outdoor activities get canceled because of the risk of tick-borne or mosquito-borne diseases, in particular triple EV. It's been here in Massachusetts, we've seen reports that really go beyond anything we've seen since the 1950s. So it is certainly a standout year, but in some respects part of just the natural cycle of these things, and I'd like to address that a little bit. I also want to do what I've done before when we talk about tick encounter and just point you to some really trusted resources that you can get further information. We don't, in this 50 or 60 minutes that we have together, I'm not going to be able to cover everything, but I would tell you that the Tick Encounter Resource Center at University of Rhode Island is a very good source of information for basic biology about ticks and how to control them and how to identify them and that kind of thing. And of course, I always cite Dr. Kirby Stafford's handbook. This is a, I don't know, 60-page handbook that he put together several years ago. It's still quite up to date. He says that he's working on an updated version. We've linked it on our page. The link is shown there below at tickdiseases.org. You can go and download this free PDF and then read it online or print it out if you care to. It's quite comprehensive. It cites a lot of the basic literature about our current understanding of the best practices for reducing ticks and tick-borne diseases. And I cite it quite often, and I think it's something that many people would want to have in their library, either electronically or as a printed copy. I also want to cite, I haven't necessarily paid enough attention to this before, but I want to cite our friend and colleague Larry Dapsis at Cape Cod Extension. Larry's put together a very good program there, and while his charge is to protect the folks on Cape Cod or to notify the people on Cape Cod, the program has been so exceptionally received that it's really resonated outside of Barnstable County, and Larry's done a terrific job. Among the things that he's put together is a series of videos, which he calls the Tickology Project, was supported by Cape Cod Healthcare there on Cape Cod. And Larry has a section of 7 to 15-minute videos that describe different aspects of tick biology. You can see the topics there from his YouTube page, different tick species, and then recommendations for how you can protect yourself, including tick perimeter yard sprays, skin repellents, and Prometheus treated clothing. It's a really well done thing. Larry's a very sharp guy, knows a lot about this, and does a very nice job of giving a message that's clear and even adds a little bit of humor. So we recommend it very highly. So those are 3 sources, and I'll show links again to these at in the summary slide at the end. And then, of course, lastly, I would point you to our own webpage. So I'm going to show you a little bit of the passive surveillance database that we're collecting. We test ticks that are human biting ticks, or in some cases, biting companion animals. And we're finding that that's a tremendous resource for determining where and when risks occur. And that's just invaluable to the whole picture. So what I want to focus on today is I'm going to talk a little bit about risk of mosquito-borne to a certain extent, and more about tick-borne diseases in time and space. And no, I'm not getting metaphysical about this. What I'm really wanting to focus on is that we should bear in mind that there's a seasonality and a geographic component, a spatial component to where these risks occur and when they occur. And part of that spatial distribution, including in addition to geography, is sort of the host distribution. So where the mosquitoes or ticks are feeding, or who they're feeding on, can be an important determinant of risk. And I wanted to start here because a number of the questions I saw in our survey were related to what's the best approach to killing ticks or to controlling ticks. And I think the answer to that question is it depends. It depends on where you are in the season and or where you are located geographically. And so again, what might work in one place at one time may be relatively ineffective at another place and time. And something that's done at a particular time may or may not have long-term impacts. And so I wanted to sort of address that by addressing some aspects of the biology of the organisms involved. So we will talk a little bit about the differences between the 3 major species of human-biting ticks found here in the northeastern United States. That's the deer tick, the dog tick, and the Lone Star tick. And I'd emphasize these are not exclusively, there's not the only human-biting ticks, but they are predominantly accounting for, I don't know, better than 96% of the human-biting activity that we're seeing in the Northeast. At the top are the names of the species, the common species, and then pictures of the adults, both males and females, on the top 2 ticks in each red box, and then the larval and nymphal ticks below them. So you can see the differences in the color patterns. I would emphasize also that these are pictures that you'll see everywhere, and emphasize that these are ticks that are unfed. So these are ticks that are flat, and so some of the coloration and marks that you see on the back of the tick, those disappear or they become less prevalent as the tick begins to feed. So to a certain extent, for human biting ticks, these images don't necessarily serve as a best means of discerning between the species. Nonetheless, if the ticks are unfed, this is basically what they look like. Below those boxes, I put a list, not necessarily a comprehensive list, but a list of the pathogens that are associated with the different tick species. So the big concern is always about Lyme borreliosis. This is Lyme disease, also known as Lyme disease, caused by a spirochete bacterium called Borrelia burgdorferi. But there are other species that are transmitted by these ticks as well, including Babesia, Anaplasma, and then the deer tick virus, or type 2 Powassan virus. There's also a new Borrelia called Borrelia miyamotoi, new in that it's recently emerged in North America, or recently been identified as a pathogen. These are, I should say that these are commonly referred to as co-infections, which can sometimes be a little bit misleading, because one should not think that this is Lyme disease plus. This is a series of independent pathogens that are acquired in the course of the tick's lifetime that can be transmitted independently. So for example, a tick may be infected with any single one of those and not with any other ones. So a tick may be infected with Babesia and not have Lyme disease. In general, ticks tend to be infected with 2 of them just because Lyme disease is so much more prevalent. And so just by the rules of probability, it tends to be more commonly associated with other infections. But there's no necessity of having both infections. And then the infections that are associated with dog ticks and Lone Star ticks are shown down below. They are rarer, much rarer, tend to be relatively infrequent in the ticks that are biting people or biting our companion animals. I also draw just a little bit of attention to this one over here. This is the one disease associated with tick bites that's not caused by, or not currently believed to be caused by, a pathogen, but rather is associated with the red meat allergy that's associated with exposure to a sugar that's found in the flesh, the muscle tissue of mammals, all mammals except for primates. And seemingly there's exposure that occurs in the bite of a Lone Star tick that induces allergy to that sugar, so that when one eats red meat, one develops allergic response to those symptoms. I'm currently serving on the SUM panel that's preparing the report to Congress that is going to describe courses of action on this. There's still a lot of things that need to be understood about how that red meat allergy is, what causes it, whether it's always associated with Lone Star ticks or other ticks can transmit it. There's still a lot of questions to evolve there. And maybe we could spend a whole webinar talking about the current understanding of that alone. So my charge is to talk about ticks, but I can't ignore mosquitoes because of the risk here in Massachusetts. And I thought I'd just give a little bit of a tail of the tape for that situation. There are more than 50 species of mosquitoes here found in Massachusetts. They vary in terms of their host preferences. Some of them eat almost exclusively on birds. Others prefer mammals. Some of them feed on both mammals and birds. And it's that last category, the ones that feed on birds and mammals, that pose some of the most serious risks to human health, because the viruses, a list shown there, EEV, Eastern Equine Encephalitis virus, or West Nile virus, and less commonly Zika, dengue, and chikungunya, these are really viruses that are predominant, in the case of EEV and West Nile virus, they're predominant in birds, and the mosquitoes transmit the viruses from bird to bird, and they become really a problem for us when a different species of mosquito feeds on the bird and then transmits it to the mammalian host, either us or, as we know, horses as well can be infected with these pathogens. Unlike most of the diseases that are common in ticks, the common mosquito-borne diseases are viruses, so the treatments available are more limited because standard antibiotics don't work. There are antivirals that are available, but mostly treatment for extreme circumstances of encephalitis involve more palliative treatments rather than curative doses of antibiotics or antivirals. And then, of course, heartworm is transmitted. Heartworm is the one example of a non-viral pathogen transmitted by mosquitoes to our pets. The reason we're talking about this is there's been more than a dozen cases of EEV this year of Eastern Equine Encephalitis virus, and that's extraordinary. As I said, first time, probably the greatest number since the 1950s. And so there's a great deal of concern because the fatality rate of these infections is very high. So that's caused a lot of alarm. It's led to aerial spraying, which is usually the last measure that one would exercise to control mosquitoes. But it's really the final, the best step towards trying to reduce that risk is trying to reduce the source of mosquitoes. Happily, we're at a state now where the mosquito season is coming to an end. Mosquitoes, unlike ticks, are their annual cycle is punctuated by a cold frost, by a hard frost. And so with the onset of cold weather, we had a hard frost here a week or so ago, and that sort of punctuates, as I say, the end of the mosquito season, and then things won't start till next year. So that's where I'd like to start by introducing the concept of seasonal distributions and risk by thinking about the differences between mosquitoes and ticks, and hopefully that will help us to better understand the two of them. So my little diagram here is just meant to show the seasons of spring, summer, fall, and winter. And if we were to look at the seasonal distribution of mosquitoes, we would find that eggs come out sometime in the, or eggs that have overwintered will hatch out larvae sometime in the spring. The larvae will develop in the water, so that's major difference between ticks and mosquitoes, is that mosquitoes are dependent on an aquatic life phase, early life stage. And those larval forms are planktonic. They swim around in fresh water or brackish water in some cases, some certain species. And they're free living, they're not parasitic. They eventually will develop into a pupa, which generally don't eat. They're just a developmental intermediate between the larva and the adult. And then eventually the pupae will emerge, and that's the first instance of what we think of as a mosquito, which is the thing that will fly around. And the females look for blood meals on birds or mammals or humans in many cases, or the males are basically not feeding off blood meal, often don't feed at all, but look for adult females to reproduce and then lay their eggs. So depending on which of the 50 species we're talking about here in Massachusetts, they may have multiple life cycles in the course of the summer. So you might have larva pupa adults repeated several times over the course of the summer, and that leads to an amplification of the populations in a given year. One of the reasons we think there's been such a serious risk for triple EV this year is that the abundance of mosquitoes was driven by a very, very wet spring, which meant lots of habitat for larvae and pupae, and resulted in lots of adults. And when it starts early with lots of water, you get this amplification over the summer. But again, as soon as you get to that cold frost that occurs sometime in the late summer, or sometime in the early or mid-fall, the season is truncated, the season is punctuated, the adults all die, and then in most cases, the species will overwinter as eggs. So it's not to say that the mosquitoes disappear, it's to say that the adult mosquitoes are no longer active after that hard frost, and the eggs will be retained in the leaf detritus in the bottom of a pond and ready to emerge for the next year. Ticks are an entirely different scenario. So here I'm showing the seasonal activity of the deer tick. And the first thing you'll notice is that I have 2 cycles of those 4 seasons. And that's to represent that deer ticks have a 2-year life cycle. So I've started in the adult stage at the far left, and I point out that the eggs are laid by those gravid females sometime in the spring. Over the course of the summer, they will hatch and emerge as larvae in the period of August into just about now, early October. Then those larvae will take a blood meal and either overwinter as fed larvae, or they'll be emergent in sometime, and they will emerge as nymphs the following spring. The nymphs then take a single blood meal again, and then they will grow up to adults, which will sexually differentiate and become breeding populations for the succeeding years. So I put years down below just to give you some indication of what this looks like. So if you can imagine that these ticks sort of overlap between cohorts, such that the 2017 cohort has nymphs and adults that are correspondent to the eggs and larvae of the 2018 cohort, if that makes any sense. So the 2-year life cycle creates this situation where you have nymphs, which are actually the older ticks, preceding in a given year the larvae, which are the younger ticks. And that's really the reason that Lyme disease cycle occurs, because these nymphal ticks are transmitting infection to mice, which then later in that same summer serve as the source of infection for larval ticks, which for most pathogens, the larval ticks are born without that infection. A couple of other things for us to take home here in terms of our conversations we can have about control is that you can imagine that if you we're doing some very effective control of nymphs in a given year, that while that may affect adults in that later that year and or the next year, it's probably not going to affect the larval populations of the year in which you treated the nymphs, because those larvae were derived from a population that you have not treated. So it's important to sort of bear that in mind. Likewise, if you were to treat larvae in a given population, you may not expect to see a real dividend in terms of the reduction of the number of ticks until the following year, when you see a reduction in the number of nymphs. So that's a complexity of the life cycle that has to go into consideration when one's thinking about how you're going to do long-term source reduction, or how you're going to reduce the populations of ticks. So I'd like to just show a little bit of data just to make this real from our passive surveillance. So these are data that you can download from tickreport.com/stats. You can look at these yourself. These are data for all of 2017. These are the deer ticks, the dogs ticks, and the Lone Star ticks that we've received. You see along this axis is the number of ticks, and then down below I put the month corresponding to the for week by week, and then over all the months of a given year for 2017. So, and just to emphasize that if you were to go and download these data yourself, you could restrict the search to just your state, or you could restrict it to a zip code, or you could restrict it to a particular species. There's some search tools that we have there that allow you to customize these views. I've done this one for basically all our data set for deer ticks, dog ticks, and Lone Star ticks. And what I can show you here, it should be very apparent, is if you see the two cycles or the two peak periods of adult ticks, one in the spring and one that occurs again in the fall. And if you look close, this is deer ticks, excuse me. The two seasons of seasonalities of deer ticks. One is in the spring, summer, then a lull here in the August, September, which I can speak to in a moment, and then a second cycle, which is going to start right about now. And if you look in the background, you can see the activity cycles of Lone Star ticks and dog ticks. So the message here is that while the risk of exposure to Lone Stars and dog ticks is lower, it's also more restricted to the summer months and pretty much has waned off by September, and we don't see a second peak in the fall. That's distinct from deer ticks, where we see this early summer, then a lull, and then a fall period. So these data are for 2017. So if you can just sort of picture that in your eye and see the scale of these bars and these bars, and then I'll forward to 2018. And you can see there's a skew here. So in 2018, we received more ticks in the spring-summer period and sort of a lull in the fall period. And I show this because we're often asked about whether it's a big tick year or a small tick year. There are fluctuations in the numbers of ticks and the degree of these tick densities, but we really think that for the most part, these are just sort of random fluctuations, and that a lot of what we're seeing is the same cycle. There's a spring season and there's a fall season for deer ticks, and then there's just a summer season for dog ticks and Lone Star ticks. And the amplitude of these may vary a little bit from year to year, and there may be lots of reasons for that, including awareness of our program, because these are all ticks that have bitten humans. And then I'll just show now 2019. So here you see another pattern. So here we haven't yet seen the second cycle, because we are only in the second week of October. But if you were to go back and compare the three graphs, you'd see that, again, there's a peak. This one tends to be a little bit more dispersed in that it started a little earlier in the spring, went a little bit longer into July, and yet there were still more deer ticks than there were dog ticks or Lone Star ticks. So I want to speak to this seasonality. So now I want to just focus for a moment just on the deer tick activity for the year of 2017 and sort of see what's underlying that distribution. So here I've broken down the distribution of deer ticks by adults, nymphs, and larvae. So you'll have to look closely to see the larvae. They're these small bars that occur between July and August, or sorry, early August and into October. And then the adult ticks, as we said before, they have these two peaks. There's the spring adults that wane off starting in June, and then the fall adults that start in October and basically occur until we see snow on the ground. Behind that is the distribution of nymphal ticks, which starts slowly in April, sort of reaches a peak in late June, runs through the July, and starts waning off by August. This is the 2-year life cycle story that I showed you before, and here's the overlapping distribution of the fall and spring adult ticks. Now, there's a few things to make note of here. One is that since every one of these adult ticks started off at some point in its life as a nymphal tick, logically, there must have been at some point more nymphs than there are adults. Likewise, since every one of these larvae is going to give rise to a nymphal tick in the next stage, logically there must be more larvae because there must be some attrition. And so part of the reason we think we see so few larvae during this period is just that they're so small and they go undetected in human biting cases. And so we've really tried to encourage people to be more actively looking for ticks in this period because they're so much smaller. But I also would like to show something else that it's amazing to me, just in talking with friends and colleagues, family, friends, people say, boy, right about this time of year, people say, boy, it seems like the ticks haven't been that bad this year. And the reason I think for that is what they're remembering is this lull in activity that occurs from right about now back to sometime in early August, which corresponds to, again, that lack of activity of nymphs and adults, the bigger ticks that we find, and a more predominant activity period for the larval ticks. But nonetheless, this happens every year. Every year there's a reduction in nymphs and adults that starts in August, continues through October. And somehow people's collective memory, they don't seem to remember it that way. But in point of fact, this is the lull in activity. And then the other reason that people ask why that is, and I think the simple answer is that there's a seasonality to ticks so that they are coordinating their life cycles in such a way that the adult females and adult males are active at around about the same time. Otherwise, they just wouldn't be able to find each other and mate and continue in generations. So there's a bit of selection that's built into this, that they have a timing that satisfies the completion of their life cycle. So that's the seasonality. So if we were to think about how to control ticks, as I said before, we'd want a strategy that incorporates effective treatment of the adult ticks, the nymphal ticks, and the larval ticks, and we should know that they occur at different times and in different places. So, for example, the geographic distribution of the major tick species, the black-legged tick, the Lone Star tick, and the dog tick, are overlapping, but not exactly the same. So the black-legged tick has this distribution basically east of the Mississippi, 2 major foci in the upper Northeast and the upper Midwest, whereas Lone Star ticks have been generally restricted further to the south, although they are expanding their ranges northward. And now we have established populations of Lone Star ticks here, even in Massachusetts. And then, of course, the American dog tick, which has mostly an eastern distribution. We think this may actually be a separate subspecies or even a separate species based on some preliminary DNA work we've been doing. I've not shown here, there were some questions about newly invasive tick species. The Asian longhorn tick is a new arrival to North America. It's now found in a dozen or so states. It seems to be established pretty well in each of those states, starting out with New Jersey. Has not been associated thus far with any transmission of pathogens here in North America. It is known to transmit pathogens in its native habitats or its its endemic sites, for example, in New Zealand, but so far, stay tuned, it doesn't seem to be a big transmitter of pathogens at this time. Probably underscores another point. So the question was, one of the questions that was asked is whether we would talk about invasive tick species. Arguably, Haemaphysalis longicornis, the longhorned tick, is an invasive species. It's new to the continent. But one could make the same or similar arguments for things like Lone Star ticks, which are invading new habitats. So too black-legged ticks, which 100 years ago or so, or even 50 years ago, did not have this widespread distribution in the Northeast. So they are also invasive species of a sort. Although very typically invasive species are thought of in an ecological context as somehow drastically changing or being changed by altered environmental conditions, I would argue that the real invader in the case of black-legged ticks is not so much the tick itself, but its host, which is the white-tailed deer. And it's been the proliferation of white-tailed deer since really the start of the 20th century, but it picked up some speed around World War II. That's what drove, that's the ecological change that probably drove the expansion of black-legged ticks. There's been some speculation that global warming or climate change has had some impact on this as well. We can't say that it hasn't, but clearly the distribution of white-tailed deer, which doesn't seem to necessarily correlate as much to climate change as it does to change in human landscaping, has driven a lot of the expansion of these species. And I would emphasize, as I had before, that the distribution of black-legged ticks doesn't necessarily completely explain the distribution of reported cases of Lyme disease. So if you recall, there's a lot of, there is a population of black-legged ticks in the Southeast, and yet the prevalence of Lyme disease in the South is not nearly that we see in the Northeast or this focus in the upper Midwest. And so there may be some different factors contributing to the risk that aren't apparent just from the tick species alone. And we know that the ranges of these ticks have expanded since in the past several years, or I should say the past couple of decades. Okay, so to the question of how to control ticks or how to prevent tick bites, we like to emphasize that the approaches should be multi-pronged and redundant. That the way to protect individuals from human biting, from being bitten by ticks, is to incorporate multiple steps. The first being just a personal protection step. There's a lot that you can do just in terms of the clothing you wear. We suggest that you wear light colored clothing and consider this time-honored tradition of tucking pant legs into the socks. And the notion here is that the light colored clothing, first of all, is easy to see the ticks, the darker ticks, against the lighter material. And tucking in the socks is just adhering to the fact that ticks tend to crawl up. And so if they crawl up and on the outside of the clothing, as in the case of the bloused sock, the bloused pant leg here, that you will be more likely to either find it and pull it off or brush it off as you're walking than if the tick crawled up the sock leg and then inside the pant leg, where it might go unnoticed and actually engage in the biting behavior before it gets detected. And then part and parcel with this personal protection is, of course, to check for ticks daily, if not more frequently, particularly when one is in areas where we know ticks are common, on trailheads or in the garden or certain parts of lawns. There are other personal protections that can be taken beyond just appropriate clothing. And the one that we think is a real champion is the use of permethrin to treat clothing. So a permethrin is an acaricide, has a very good safety profile. I should note that it's it's poisonous to cats, so you wouldn't want to treat your cat or to let your cat be exposed to a place where they could drink the permethrin. But for people and other pets, it tends to be quite safe. In fact, most bug dopes that you'll see in the feed stores for treating horses contain permethrin. It has a high safety profile in that it's very, very deadly to ticks, but very, very safe for human use, or generally safe for human use. And the reason it's used to treat the clothing is it's really been engineered to adhere to the fabrics. It remains in the fabric for several washes, and it's important to remember that this is an acaricide, meaning that it kills ticks. It kills them as opposed to repelling them. And it's actually more of a general insecticide, so it will also kill mosquitoes. So the same article of clothing that you're using to protect yourself from a tick bite will also protect you from a mosquito bite. As I'll say in a moment, because it's a general insecticide, it also works against things like pollinators, like honeybees and bumblebees. And so in that regard, it's not necessarily a desirable thing. However, because the acaricide is treated to the clothing and not broadcast, we think this is a pretty safe use of it in terms of protecting pollinators and other wanted or desired entomological species. So the other consideration for personal protections are repellents. So unlike acaricides, which kill ticks and mosquitoes, repellents are meant to either confuse the search pattern of the mosquito or the tick, or to actually repel the mosquito or tick from wanting to bite a particular area. So these products are applied to the skin. The most effective ones contain DEET. There are other products that have been recommended, including picaridin, that seem to be relatively effective, but things like many of the essential oils don't have the same efficacy as that DEET shows. And so we rarely recommend DEET as a repellent for ticks. For mosquitoes, this prevents the mosquito it prevents the mosquito from identifying the host and then engaging the host, whereas for ticks, it serves more as a repellent for ticks. Once they are on the body, they'll avoid biting in places where the repellent has been applied. So those are the protections that one can do for personal protection. You can wear appropriate clothing. You can use different chemistries for treating, for killing ticks or repelling ticks from your person. But then there are things, of course, that can be done to reduce the source of ticks in the wild. And one of those that's commonly used by perhaps a number of people on the webinar today are perimeter sprays. So use of acaricide, some of the same synthetic pyrethroids that are used for treating clothing can also be used as chemical yard sprays. So the notion here is to create a protective barrier around a property. So if you can imagine a lawn that's where children are playing, if you treat the outside, the edge, where the edge habitat where the ticks are most likely to be found, you can create a protective boundary which is persistent for several weeks. So the permethrin is sprayed on the vegetation. It will persist there for a number of days. It doesn't get washed away very effectively because it's not water soluble. But it also doesn't have a long-term residual impact the way things like DDT do. So you recall that DDT was problematic because it accumulated in the environment and worked its way up through the food chain. In the case of these synthetic pyrethroids, after a couple of weeks, they're broken down by soil microbes and no longer become active. And so they have a limitation to their activity period. The video series that I recommended, but from Larry Dapsis, has a nice presentation of how a perimeter spray can be done by a homeowner, and would reflect something similar to the picture shown here, where a professional applicator has been is applying a perimeter spray to a yard. Other types of treatments, so this is, I'm going to show these very quickly. One of the ways that we can characterize the behaviors or the biology of ticks is by the number of species of hosts that they feed upon, or the number of host specimens. So there are some ticks which feed on just a single host throughout their lifetime. And by that I mean they literally will take all three blood stages as a larva, a nymph, and an adult on the same species, on the same animal. And those are called one-tick hosts. So trying to control a one-tick host in many ways can be easier than trying to control a two-tick host, because obviously in the case of a one-tick host, you only have to worry about one treatment if you're trying to target the host as the source for reducing numbers of ticks. Two-host ticks are slightly more complicated. If you're trying to protect a domesticated animal, but you also have a host that's a wild animal, then you are faced with a problem that you may not be able to reduce the ultimate source if you can't access that wild animal. And of course, this becomes even more complicated in the case of three-tick hosts, where there may be two or more wild host species that are feeding juvenile stages. All three of the ticks that we have here, and human-biting ticks that we have in the Northeast, are three-host ticks. So they all feed on different hosts during their larval, nymphal, and adult stages. Now, there's a distinction to be made here. In the case of deer ticks, the juvenile stages feed on small mammals predominantly, mostly white-footed mice. And then as adults, they feed almost exclusively on white-tailed deer. But the important point is that the specific animal that these juveniles feed on is not the same. So they'll feed on one mouse as a larva, and then another mouse as a nymph, and then a deer as an adult. That's to distinguish it from something like a Lone Star tick, which can take all three of its blood meals from white-tailed deer. However, it's generally not the same white-tailed deer. So it'll feed on one deer, then another deer, and then a third deer. And in each successive stage, it will feed and then it will fall off. So that's a fundamental difference between Lone Star ticks and deer ticks, is they are all three-host ticks, and yet they feed on multiple different animals. So there are a number of different host-targeted tick control strategies, including methodologies that target deer, so four-posters being one of them. So four-posters are bait stations that treat the deer that come to the bait stations with acaricides, and theoretically will kill the deer, kill the ticks on the deer, and in doing so reduce the total number of ticks. They tend to be effective when used in higher concentrations. So what should I do? Good. Back? Okay, sorry. Seems like we lost audio there, so I'm not sure where we dropped out, but host-targeted tick controls can target deer, and four posters are an example of that. Four posters are feeding stations that feed test. Hello? I'm showing a bar here that says that the stereo microphone is working.
If we keep on losing, I don't know what's happening.
I think it's back, maybe?
It's back.
No? It's back now?
Can you hear you?
I can hear you. Can you hear me?
Yes.
I don't. Okay. So you think we're broadcasting again?
Yeah, it should, yeah.
Okay. So we're drawing to the end here. So I was trying to address the host-targeted tick control measures, and we can use methods that will prevent ticks from feeding on deer, either by four-posters, which are the baited stations that are treated with that treat the deer with a caricide, or we can just abate the number of deer. So there's much talk about reducing deer herds to an appreciable level. I will say that it's not entirely clear that that just harvesting more deer is necessarily impactful. We don't know how low how much more we have to lower those densities in order to have an appreciable impact on the deer herds. There are also methodologies out there that are considered for treating, the mice populations. So believe it or not, there's been some studies showing that you can vaccinate mice with a vaccine that's very similar to that which was used on humans and is currently used on companion animals. It can be used to treat mice in the wild, reduce infection in those mice, and hence reduce the transmission rates of things like Lyme disease. There are obviously limitations to this. Vaccinating, oh, by the way, these are oral vaccinations usually, so they're treated baits that the mice eat. But getting widespread vaccination of thousands and thousands of mice can be a real challenge, both financially and practically. There are also methodologies that can be used. Either tick tubes or bait boxes can be used to deliver acaricides to animals. So if you can draw mice into a tube where it can find a source of food, like in the case of a bait box, or bedding in the case of tick tubes, you can encourage them to either take the acaricides back to their nesting materials, as in the case of tick tubes, or in the case of bait boxes, to actually be treated by acaricide as they're feeding on those baits. I'll leave that for a moment and go to the last one here, which is really there's just one group talking about this out of MIT that is considering the release of transgenic mice, or the creation of a transgenic mouse which is refractory to infection, and to release those in the wild and basically supplant the host population in a way that would reduce the source of infection. I should say that even the practical laboratory aspects of this haven't been worked out yet, nor is it clear that this could be done in any practical sense. So below here, I put a paper by White and Gaff. This is Holly Gaff and her graduate student at the published in the Journal of Integrated Pest Management. And it's a really nice meta-analysis of all these different approaches. And it incorporates, I think, a balanced study of what's effective and where it's effective. And I think the take-home message from that is that while there are no silver bullets, there are no magic bullets that are 100% effective, there are methodologies which can be effective in some circumstances, perhaps less effective in other circumstances. So just to draw out, for example, the tick tubes, there are 3 or 4 studies that have looked at the effectiveness of tick tubes, things like Daminex, and some of them have shown it to be quite effective. Others have shown it to be not effective whatsoever. And I think what the story we should take from that is that these may not work under all conditions, but to write them off as not working at all or being a perfect solution is sort of the wrong way to think about this. So I put this here because I wish this paper was publicly available, but it's not. You would have to pay to get access to it. But perhaps in a future webinar, now that I know there's more interest in tick control, we could review all the different aspects of what Holly and her colleagues have written in this meta-analysis, and go through piece by piece and talk about the different control strategies. I'd like to just close here by just talking about the tick-borne disease risk that we've talked about before, and our assertion that the control of tick-borne diseases does not start and stop with tick control, that there are considerations to be made for where that risk really lies. And I've used this example before in saying that I think there are things you can do at the pre-tick stage when the tick bite occurs, and things you can do after the tick bite have occurred. And so for those of you that are professionals that are working with clients that are trying to mitigate risk on their properties or mitigate risk to their families, I think this is an important consideration to understand that there's a battery of tools that can be used for perimeter sprays and source reduction and tick tubes, etc. But you would do well to incorporate things that go beyond traditional tick control and remind those clients that personal protection is also every bit as important as treating their yards. Because if someone treats their yard even effectively, if they're not using personal protections when they go outside their yard, they're likely to still have the same risk. And so you may experience circumstances where you're 100% sure that you're effectively treating a given property, but you're not reducing the risk because people are being exposed to risk off-site. And so I think incorporating this multi-stage approach and thinking about the risk at the different levels can be a really effective strategy. And here at UMass, our laboratory, we see the importance of those different levels, and I would love to engage more on a individual level with those of you that are sort of developing these strategies and help you to think through how you might be able to message to your clients about the importance of not just perimeter sprays, but things that they have to do after they've done the perimeter sprays. I think it will lead to more satisfied clients for those of you that are in that professional industry. It will also lead to more favorable public health outcomes, which is what we're trying to achieve, because if you have a multi-pronged approach and redundancy built into those approaches, I think you'll see the risk is better reduced. Because as I've emphasized before, when one makes an evaluation of hazard and risk, what one is really interested in very often is exposure. And the exposure in the case of Lyme disease is not just the number of ticks that are out there, but the number of people that are actually getting sick, which is mitigated by these different exposure factors, which are which species are hazardous, how long are those ticks feeding, and what is their infection status. So I've spoken about this at length in prior webinars. And just a reminder that every bit as important as how infected the species of tick is, it's important to know how long the tick is fed, because risk increases with the time of feeding. That simple message for people who are trying to mitigate their risk or maybe applying a perimeter spray can go a long way towards preventing illness even after the tick bites have taken place. So just to summarize, I think there are 3 trusted sources for tick prevention and control methodologies. They're on Tick Encounter, Cape Cod Extension, and then our own website that provides the PDF to Kirby Stafford's manual. I think the risks should be understood to be seasonally and geographically distributed, that they're not uniform over the course of a time or space, and that knowing a little bit about that tick biology is going to help to target your responses and know what's to be expected when you treat them. So knowing, for example, that treating nymphs in a given year may not influence the number of larvae in that same year, that's an important consideration. And lastly, this final message I made about just mitigating risk should be a multi-pronged approach, and there should be redundancies built into it. Just because you may be set up to do perimeter sprays, you may want to incorporate some other messaging to your clients to ensure that they're doing practices that go above and beyond what you can do in their yards and keeping them safe there in the longer term. I think, as I say before, that will lead to happier clients and better public health outcomes. So that's what I have for today. I thank you very much for your attention and your attendance today. As always, we welcome your feedback. I look forward to doing further presentations and addressing the topics that you tell us you want to hear most about. And thank you very much.